If you open a science textbook, you'll see the same three states of matter: solid, liquid, and gas. But what if that wasn't the full story? What if there was something entirely new? Something that could change computing forever? Microsoft has just unveiled Majorana 1, a quantum processor built on a never-before-seen state of matter. This breakthrough isn't just a step forward, it's a fundamental leap in quantum computing, one that could shrink decades of progress into just a few years. How did they do it? And more importantly, what does this mean for the future of AI, medicine, and cybersecurity? Let's break it down. For years, companies like Google and IBM have been racing to build practical quantum computers. The promise is massive machines that can solve problems no supercomputer on Earth could ever touch. But there's a catch. Quantum computers rely on qubits, the quantum version of the ones and zeros in classical computing. The problem? Qubits are fragile. They're incredibly sensitive to noise and interference, making them unreliable at scale. Until now, most quantum systems have used superconducting qubits, but these require extreme cooling and still struggle with error rates that make large-scale quantum computing nearly impossible.
Productivity increases because in some sense AI does really help reduce the drudgery in a lot of our work. In fact, talking about software development, my first belief in all this technology came when I saw GitHub Copilot and what it did, because the joy of programming was something that was brought back because of AI helping me with the task in hand. So I think what AI does, quite frankly, is simultaneously reduce the floor and raise the ceiling for all of us.
Microsoft took a completely different approach. Instead of trying to improve existing qubits, they built an entirely new type of qubit, one that could finally make quantum computing practical. And it all starts with an elusive, almost mythical particle. In the world of physics, some discoveries change everything. The Majorana particle is one of them. First theorized nearly a century ago, the Majorana particle is unique because it's its own antiparticle. That means if two of these particles meet, they can either cancel each other out into nothing, or remain as two distinct entities. This strange behavior isn't just a physics curiosity, it's the key to Microsoft's breakthrough. Last year, scientists were able to observe the Majorana particle for the first time. But this year, Microsoft has done something far bigger. They've harnessed its properties to build a completely new type of material, what they call a topoconductor. This is a new state of matter, engineered at the atomic level, and it's what allows them to create topological qubits, a type of qubit that's smaller, more stable, and far less prone to errors. With this, Microsoft believes they've solved the biggest obstacle in quantum computing, and now, they're ready to scale. But just how powerful is this new technology? Let's talk about the Majorana 1 chip. This is where everything comes together. Microsoft has taken the power of Majorana particles and built them into a revolutionary processor, Majorana 1. Unlike traditional quantum chips, which rely on unstable qubits, Majorana 1 uses topological qubits, which are far more stable, reliable, and scalable. It all comes down to the topoconductor, the new state of matter Microsoft engineered. This material allows their qubits to be smaller, just 1/100th of a millimeter in size, more reliable, less interference, fewer errors, and scalable. Instead of just tens or hundreds of qubits, Microsoft believes this design can support millions all on a single chip. To put that into perspective, today's quantum computers are powerful but nowhere near ready for large-scale industrial applications. Majorana 1, on the other hand, could bring real-world quantum computing within reach, not in decades, but in just a few years. But what does that actually mean? What kind of problems could a quantum computer like this solve? Let's talk about the real-world impact of Majorana 1. A million-qubit quantum processor isn't just a technological milestone, it's a game-changer for the entire world. If Majorana 1 delivers what Microsoft promises, the impact will be unlike anything we've seen before. Take medicine, for example. Quantum computers could simulate molecular interactions at an unimaginable level of detail, leading to faster drug discoveries and personalized treatments. Diseases that take years to research could be understood in weeks or days. Then there's artificial intelligence. AI models today are limited by classical computing power. With quantum processing, they could train orders of magnitude faster, unlocking capabilities we can't even predict yet. And cybersecurity? That's where things get really interesting. Quantum computers have the potential to break traditional encryption, but Microsoft's approach suggests they're not just building quantum computers, they're preparing for a post-quantum world where new forms of security will be necessary. Climate modeling, logistics, financial systems, every industry that relies on massive computation could be transformed. But there's still one big question. How soon will this happen? Let's talk about Microsoft's timeline. For years, quantum computing has felt like a future technology always decades away from being useful. But Microsoft is saying something different. Majorana 1 isn't a distant dream. It's happening now. According to Microsoft CEO Satya Nadella, this isn't just an incremental improvement, it's a fundamental leap in computing. Instead of waiting decades for practical quantum machines, this new approach could bring real-world applications in just a few years. And they're not just theorizing. Microsoft has already demonstrated control over Majorana particles, built a chip based on them, and designed an entirely new topological quantum architecture. The next step, scaling up. With the potential for millions of qubits on a single chip, Microsoft believes this breakthrough will lead to industrial-scale quantum computing faster than anyone expected. The race for quantum supremacy is heating up, and with Majorana 1, Microsoft may have just taken the lead. Majorana 1 is a breakthrough, but it's not the end of the journey, it's the beginning. Even with Microsoft's new topological qubit design, scaling quantum computers to millions of qubits won't be easy. There are three major challenges that still need to be solved. Number 1, manufacturing at scale. Engineering a quantum chip using a new state of matter is unlike anything in traditional semiconductor production. Every single atom in the chip has to be placed with absolute precision, a process that still needs to be refined for mass production. Number 2, error correction and stability. While topological qubits are more stable than other designs, quantum computing still requires an extremely controlled environment. Maintaining coherence, the ability of qubits to stay in a superposition state over longer periods, is a major hurdle. Number 3, integration with existing systems. Quantum computers won't replace classical computers, they'll work alongside them. But creating software, algorithms, and cloud-based access to quantum computing is a massive technical challenge that still needs to be addressed. Microsoft is confident that these challenges can be solved, but the timeline depends on how quickly these barriers can be overcome. Which raises another question. What happens when we finally reach large-scale quantum computing? If Microsoft is right, if Majorana 1 really does lead to practical, industrial-scale quantum computing, then we're looking at the biggest shift in computing history since the invention of the microprocessor. Quantum computing isn't just about making things faster, it's about solving entire classes of problems that classical computers physically can't. AI models that can self-improve at an exponential rate, new materials engineered at the atomic level, unlocking room temperature superconductors or ultra-efficient batteries, unbreakable encryption, or, conversely, the total collapse of traditional cybersecurity. We're standing at the edge of something huge. And with Microsoft's Majorana 1, the quantum era may be closer than anyone ever expected. Now, let's wrap this up. We've just entered a new era of computing, one where Microsoft's entirely new state of matter could redefine what's possible. The question isn't if quantum computing will change the world. The question is, how soon? What do you think? Comment below. And if you enjoyed this video, make sure you hit the like button, and also don't forget to subscribe to our channel for more of these kinds of videos. Thanks for watching.